Good morning. Today I begin with a new chapter. The name of the chapter is States of Matter. When we did the first chapter, I told you that chemistry is the study of matter. This matter can be classified based on the physical state into three: solid, liquid, and gas. In this chapter, we will be doing in detail about the gaseous state of matter and few properties of the liquid state. Intermolecular forces are the forces of attraction and repulsion between the interacting particles in matter. The attractive intermolecular forces are called van der Waals forces. Now we are going to study different types of van der Waals forces. The first type of van der Waals force is called dispersion force or London force. Atoms and non-polar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed. But a dipole may be developed in such atoms and molecules. This results in the development of an instantaneous dipole for a very short time. The temporary dipoles attract each other. This force of attraction is called London force or dispersion force. It is a force of attraction between two temporary dipoles. These forces are important only at short distances. Second, dipole-dipole force. Dipole-dipole forces act between the molecules possessing permanent dipole. Ends of dipole possess partial charges and these charges are shown by Greek letter delta. Partial charges are always less than the unit electronic charge. This interaction is stronger than the London force but is weaker than the iron-iron interaction because only partial charges are involved. The attractive forces decreases with the increase of distance between the dipoles. The third force is dipole-induced dipole force. This type of attractive force operates between a polar molecule having permanent dipole and the molecule lacking permanent dipole. Permanent dipole of the polar molecule induces dipole on the electrically neutral molecule by deforming its electronic charge. Thus, an induced dipole is developed in the other molecule. Here also, the induced dipole depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule. Last one, hydrogen bond. You have already studied about this in chemical bonding. It is a force of attraction which exists between highly electropositive element hydrogen on one molecule and highly electronegative elements like fluorine, nitrogen or oxygen in the other molecule. Thermal energy is the energy of a body arising from motion of its atoms or molecules. It is directly proportional to the temperature of the substance. It is a measure of average kinetic energy of the particles of the matter and is responsible for movement of the particles. Intermolecular forces tend to keep the molecules together, but thermal energy of the particles tends to keep them apart. The three states of matter are the result of balance between intermolecular forces and the thermal energy of the molecules. Now, we start with the gaseous state of matter. The gaseous state of matter has certain characteristics which are unique and different from the other states of matter. They are: first, they are highly compressible. Second, they exert pressure equally in all directions. Third, they have low density. Fourth, they don't have fixed shape and volume. And fifth, they show a property called diffusion where Gases mix evenly and completely in all proportions without any mechanical aid. Thus, the gaseous state of matter is the simplest state. In the periodic table, only 11 elements exist as gases under normal conditions.